In this video, we're going to introduce logarithmic functions, and then we'll talk about how to change between an exponential function and a log function. So first, let's start with the definition of the log function. So it's basically log base a of x equals y. So that's the way you read that. Log base a of x equals y. So what is that saying? That's saying, so the base is a, the exponent is y, and that equals x. So, when you say, log functions equal exponents. Okay? So this log function equals an exponent. So there it is. And the base of that exponent is a. All right? So let's go ahead and do an example where we have an exponential function and we need to transform it to a log function. One more thing though, actually, real quick before we do an example, I just want to mention that when I write it like this, we need a few assumptions about a. A is greater than 0, and a does not equal 1. Okay, and that's to do with this log. You can't have negative a there in the base of the log, and you can't have 1 in the base of the log. Okay, so now let's go ahead and do an example. Alright, so starting with this letter A, example A, we need to, this is in exponential form right now, and I want to write it in log form. So the base is going to be 8, right? If you were to read this, this is base 8, and then it's raised to the second power, right? And that equals 64. So the base is 8, log base 8, and x is going to be what this equals. So 64, and logs equal exponents, so the exponent is 2. So that's the way you would rewrite this in log form. Both, what I've written here and here, these are equivalent statements. They mean the same thing. All right, let's go on and do letter B. So there's actually two ways that we could do this. First, let's do it the same way we did A, and then we'll do it a different way. So the base here is 1/3, so I could write log base 1/3, and it equals 1/27th, and then this equals the exponent, which is 3. Okay. Another way I could have written this, I could have rewritten the original equation here as 3 to the negative 3 power, okay? Because 1/3 is 3 to the negative power, and then it's being brought to the third power, so that's 3 to the negative 3 equals 1/27, okay? If I were to do that, then the way I would write this, so I'd have log, and the base is still 3. Well, the base is now 3. Before it was 1/3, so that's basically the change. Okay, so now the base is 3, and so it's this 1/27 is still there, and this equals the exponent, which is negative 3. Okay, so if you were to write this in this form or in this form, they're both equivalent. Okay. All right, let's go ahead and move on to the last example. So before we can put this in exponential log form, I'm going to need to get it into a format where it's like, an exponential, like 5 to the x equals something, right? So I need to add 1 to both sides. So I'm going to go ahead and start by doing that so I can get 5 to the x by itself. 124 over 125. If I add 1, that's basically the same thing as adding 125 over 125. Okay, so this simplifies to be 1/125. Alright, so now if I were to write this in log form, the base is 5, so I write log base 5. The, what it's equaling, so this is over 1/125, okay, and then the exponent. Okay, so the log equals the exponent, which is x. Alright, so now let's go ahead and do an example where we're flipping in the other direction. So we have the log form, we're trying to put it into the exponential form. Alright, in this first one, the base is 10, Logs equal exponents, so there's the exponent. This equals 1 over 100. All right, let's do the last example here. So the base is c. Logs equal exponents, so there's the exponent, and that equals b. All right, there are your answers.